हेलो एवरीवन, गुड इवनिंग। आज के इस वीडियो में हम लोग पिछले वाले सेशन को ही कंटिन्यू करेंगे। वी विल कंटिन्यू द डिस्कशन ऑफ द प्रीवियस ईयर क्वेश्चंस। सो लेट्स ओपन द लास्ट वन। या इसी के बारे में हिंट दिया था इन द लास्ट वीडियो दैट द काइनेटिक एनर्जी ऑफ एन इलेक्ट्रॉन इज 120 इलेक्ट्रॉन वोल्ट। वी हैव टू फाइंड आउट द मोमेंटम एंड स्पीड। सो लेट्स गो टू द स्लाइड. Yeah, this one, which one is ours? Yeah, this one is ours. Okay, so they have given us the kinetic energy of the electron, na? So kinetic energy can be written as k dot E, or if you are comfortable, you can write down that the kinetic energy of electron is k. But you have to define to the examiner that I am writing kinetic energy with k. So kinetic energy is equals to 120 electron volt, but I have to convert that electron volt into joule. So it is equals to 120 into like 1.6 into 10 to the power minus 19, that much joule. What is the relation between kinetic energy and momentum? Do remember. Now kinetic energy K, it has two different relations that I said in the last video, that K is equals to of P square by of 2m, where P is actually the momentum of the electron. Otherwise we can use the same like P equals to root over of 2mk, but I think the first one is more better, na? So in this case we can use like k equals to p square by of a 2m. I need to find out the momentum. So in this case p square will be equals to twice of the mass of the electron. I am just cross multiplying with this expression. Those who are weak in calculation, for them I am just doing with some more number of lines. 120 into 1.6 into 10 to the power minus 19. So in this case, twice of 9 into 10 to the power minus 31 into of 120 into 1.6 into 10 to the power minus 19. So P equals to root over of that. So in this case, we can omit the point. We will get 1 0. That 0 can be cut. Right? Under root of 9, that is equals to of 3. Under root of 16, that gives us 4. After that, as we can see that 10 to the power minus 31 and 10 to the power minus 19, they can be added, na? So we'll do the rest of the calculation. Inside of the square root, it will become like 2 into of 12, and we can write that 10 to the power minus 31 minus 19. I hope up to that much you have understood. We are just minimizing the calculation as we don't have calculator, so we have to proceed like this. Now 12 to the 24, right? So if you want, you can just keep it like this, that 12 under root of 24 into 10 to the power, I think it is becoming of minus 15, huh? So in that case we can say like under root of 10 to the power minus 50 is 10 to the power minus 25. So 12 into 10 to the power minus 25 and under root of 24. Under root of 24, remember in the class we said that it can be taken as like 4.9 approx. So 12 into 4.9 into 10 to the power minus 25. What is the unit of momentum? That is of kilogram meter per second. Easy, na? It's so easy. After that, we have to find out, I think, the velocity. Na? They said in a question that we have to find out the velocity. At first, if you are watching this video, so you have to pause it here, you have to write it down from the beginning, then you should proceed further. This is the way of e-learning. It's not like you are watching like a movie and you just pass on the whole video. You have understood. Oh, sir, yes, I have understood. This is not the process. So pause it and write after that. I'm just moving. So P equals to of 12 into it was how much? 4.9 into 10 to the power minus 25. Okay, so 4.9 into 10 to the power minus 25. So P is equals to what? It is mass into velocity, that is of 12 into 4.9 into 10 to the power of minus 25. So in this case we can find out the value of V. It is 12 into 4.9 into 10 to the power minus 25 divided by the mass of electron. Mass of electron, I am just directly substituting the value. Okay, otherwise we can do it like this. Those students who are weak in calculation, for them, like m into v is equals to this expression, so v should be equals to the total expression by of m. M is the mass of electron. So in the next line, I am just doing for them 10 to the power minus 25 divided by of 9 into 10 to the power minus 31. What I said that you have to separate the numbers and powers. So 3 3s are 9, 3 4s are 12. 4.9 into 4 is how much? 4 9s are 36. Then 19.6 by 3 na? And 10 to the power minus 25 plus 31. I think it will come as 3 6 are 18. Then 3 5s are. Then 3 3s are na? 10 to the power 6, that much meter per second. This is the expression for velocity. This is actually the process. Actually, in physics, I don't follow the shortcuts because I believe in process only. If you can learn the process, then in that case, you are learning the physics, how to solve the numericals, how to visualize the problem. So that's why I prefer that we should read the problem more number of times so that we can understand what the question is asking. Okay, now let's go for the next of the part. A lot of lecture I give now during the problem solving. What is the next one? Momentum and speed we have found. After that, wave nature of matter. Write a few lines on any of the following. Look, Division-Germer experiment is not included in your syllabus. We can only discuss about the wave nature of matter. Wave nature of matter class में लिखा दिया था ना, है? That nature is symmetrical. If a radiation has a dual nature, matter should also exhibit its wave nature along with its particle nature. Class में बताया गया था. And what we say that for a moving particle there is some wave which is associated with it. According to de Broglie, the wavelength of that matter wave is h by p. इतना लिखना काफी है, कुछ लंबा चौड़ा पैराग्राफ नहीं लिखना है. We have to write to the point answer. Okay. Okay, इसके बाद, oh, there is a numerical question. Name the formula given below. कहाँ है formula? Oh, that is a Rydberg formula. Using the value of this is actually the value of Rydberg constant R. If needed, we don't need it. Find the wavelength of H alpha line and arrange H alpha, H beta, H gamma lines in the spectrum of hydrogen. अब ऐसा आएगा कि हमने तो ये तो कभी नहीं पढ़ा. H अल्फा, H बीटा, H गामा, ये तो ना तो एनसीईआरटी में अच्छे से दिया हुआ है ना कहीं पे है. बट वी शुड डिस्कस. H अल्फा, H बीटा, H गामा क्या है देख लो. This question is related to the line emission spectrum of hydrogen. So let's move for the slide. We can say that in the case of a line emission spectrum of a hydrogen, पहले तो हमें लाइमन सीरीज मिलता है, उसके बाद बाल्मर सीरीज मिलता है. अब आप लोग का मेमोरी इतना अच्छा है कि शायद आप लोग भूल गए हैं. सो दैट्स व्हाई विल जस्ट मेक अ वेरी शॉर्ट डायग्राम याद दिलाने के लिए. That this is actually the ground state, that is of n equals to 1. After that we had drawn this is n equals to 2, and this is your n equals to 3. After that n equals to 4, then n equals to 5, n equals to 6, n equals to 7. All these energy levels they exist. Okay, but electron can move in any of the energy level whenever it is getting the energy from some external source. Okay, by the collision of electron we can provide the energy. So we say that the last one is actually n equals to infinity ना. ये तो बहुत ज़्यादा गैप हो गया, इनके बीच में एक और बना देते हैं तो देखने में अच्छा लगेगा. So along that vertical axis we plot that the total energy should be in electron volt. So we have to write it in a bracket. It should be in electron volt. The minimum energy, that is minus 13.6. After that minus of 3.4. Then it should be of minus 1.51. Then minus 0.85 and it continues. The next term should be minus 0.54. For the case of a Balmer series, electron कहाँ पे आ रहा है? It is coming in the second orbit ना. So whenever the electron is making a shortest transition, third orbit से second orbit तक, शॉर्टेस्ट ट्रांजिशन के लिए आपको लॉन्गेस्ट वेवलेंथ मिलता है. याद है मैंने क्लास में कहा था, फॉर शॉर्टेस्ट ट्रांजिशन वी विल गेट द मैक्सिमम वेवलेंथ. सो इन दैट केस विजिबल स्पेक्ट्रम जो हमें बाल्मर सीरीज के लिए मिलता है उसमें लॉन्गेस्ट वेवलेंथ किसका होगा? ऑब्वियसली रेड का. सो दिस इज एक्चुअली द फर्स्ट line that we are getting. This is known as H alpha line. After that we'll just get a bluish line. So this is actually that bluish line, we can just call it, this is H beta, and the next one is actually a violet color line we just get. Okay, so we can see this is for H gamma. थोड़ा थोड़ा दिख रहा होगा ना लास्ट वाला. So in that formula, we will just use it that for the case of hydrogen, they have given the Rydberg formula like 1 by lambda is equals to R into 1 by of 2 square minus 1 by of n square. We have to find out the wavelength for these three different lines. Okay. After that arrange भी करना था, पर किस ऑर्डर में करना था मैंने क्वेश्चन को लास्ट में पढ़ा नहीं है, बाद में देख लेंगे. So for the case of H alpha line, we will just find out the wavelength. For H alpha line, you can see this is actually your lambda 1. So 1 by lambda 1 that is equals to R into of, यहाँ पे 2 इसलिए लिखा हुआ है because this is actually the orbit where the electron is coming and n is the orbit from which the electron is coming. So for the case of H alpha line, the electron is coming from n equals to 3 ना, तो यहाँ पे लिखना चाहिए 1 by 3 square. अब इसका कैलकुलेशन मैं पहले क्लास में करवा चुका हूँ, आप लोगों को याद नहीं है तो क्या ही करें. अब इसका कैलकुलेशन दोबारा से करने की ज़रूरत नहीं, कॉपी खोलना है, सिंपली वहाँ से देखना है. इट विल कम एज 5 by 36. इसके बाद का कैलकुलेशन है तो लैम्डा 1 का वैल्यू आपको मिल जाएगा. Similarly, for H beta line, what we can say that I should write as 1 by lambda 2 and R multiplied by 1 by 2 square minus कौन से ऑर्बिट से आ रहा है? I think it is coming from fourth orbit ना, so it will be 1 by 4 square. ये वाला कैलकुलेशन हम लोगों ने नहीं किया था, तो 1 by lambda 2 that is equals to of, ओहो पिछले वाले में एक छोटा सा मिस्टेक हो गया मुझसे, अभी अभी देखा, आर को तो मैं पलटना ही भूल गया. ओहो सॉरी 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 सॉरी, गलती मेरा ही है. अगला वाला लाइन तो मैंने किया नहीं है, आप लोग के लिए कर देता हूँ. मैं गलती से पिछले वाले लाइन में पूछ दिया. एक्चुअली ये गलती है नहीं क्योंकि मैंने डायरेक्टली आंसर मांगा था आप लोगों से. चलो पलट देते हैं. lambda 1 should be 1 by r into of 36 by 5. After that I hope you can do the calculation. यहाँ पे करते हुए मुझे याद आया, now it should be 1 by 4 minus 1 by 16. इसके बाद का कैलकुलेशन आप लोग खुद कर सकते हो शायद, right? Like it will come as 3 by 16. Okay, so lambda 2 will give you the expression as 1 by r into 16 by 3. ऐसा ही कुछ आएगा, आप लोग चेक करो फिर बताओ. उसी तरीके से lambda 3 भी निकाल लेना for the H gamma line and then arrange in whatever the way they want. उसके बाद मुझे आंसर बताना कि आया कि नहीं. Okay, let's move on. Oh, there is a call, so I have to pause it.